Okay, so this video we're going to tackle a couple of the word problems that you'll find in the linear equations problem set and stuff. So this one we have a local hamburger shop sold a combined total of 376 hamburgers and cheeseburgers on Friday, and there were 74 fewer cheeseburgers sold than hamburgers. So how many hamburgers were sold on Friday? So when I tackle word problems and stuff, the first thing is just to read the entire problem. And just kind of identify things that you're given and you know what the actual questions is asking, things like that. Don't try to work it out as you go along. Just read it and understand the problem first. Then I go through and I look for keywords. Okay, so like here it says there's a total of 376. So when you see the word total, that means what? You have to add stuff up, just like the total on your bill at a restaurant. You add up all of the items, right? So here we know we're adding some stuff together. And there's also 74 fewer cheeseburgers. So fewer, if there's 74 fewer, then that means I'm going to have to subtract something. So I've got a couple of equations kind of going on here then. And dropping my pen and making stuff. So the next thing is just identify what the unknowns are and assign some kind of variable to them. So the things that are unknown right now are how many hamburgers and how many cheeseburgers there are. So you know what? I'm going to call H the number of hamburgers, and C will be the number of cheeseburgers. So now let's go back to, says we have a total of the two are 376. So I know if I add those two cheeseburgers up, if I add the number of hamburgers and the number of cheeseburgers, that's going to be 376 of them. And I also know that there's 74 fewer cheeseburgers than hamburgers. Okay, so 74 fewer cheeseburgers than hamburgers. So if I take the number of hamburgers, okay, and the number of cheeseburgers, how do those two compare? So 74 fewer cheeseburgers. So the number of hamburgers minus the 74 should equal the number of cheeseburgers, because there's 74 less, right? So that gives us two equations that we can work with, and we can use our system of equations stuff to solve this. Oh, let me scroll back there, sorry. So I'm going to, since I have one equation where it's already solved for one variable, I'm going to go ahead and use the substitution method. And because this is solved for C, so I'm going to take, I just circled the wrong side. So I'm going to take this, since I know that's equal to C, and substitute it into the other equation. So that's going to give me H plus, and then H minus 74, because that's our C, correct? 376. And now I've just got an equation with one single equation with one variable. And I can simplify, so I'll combine my like terms. And now I'm going to undo the addition stuff first. So we're going to add 76 to both sides. 74. And that's going to give me, what, let's see if we add 74. It's going to be 2H equals 450. And then I'll divide both sides by 2. And that means the number of hamburgers I sell is 225. Now, if you go back to the question, it says how many hamburgers were sold, right? That was the end. How many hamburgers were sold on Friday? So we already know our answer, so we don't need to find the number of cheeseburgers. So remember, just take your time to answer the question. Don't find extra stuff if you don't have to, because it's just kind of a waste of time. So the next word problem I have, Sam was choosing between two exercise routines. In routine 1, She does only running, burning 10.5 calories per minute. In routine 2, she burns 26 calories walking. Then she runs at a rate that burns 5.3 calories per minute. For what amounts of time spent running will routine 1 burn more calories than routine number 2? Use T for the number of minutes spent running and solve your inequality for T. So this actually gives us a couple of clues here too. So we're going to use T for the number of minutes running, okay? And also it means we need to set up an inequality, correct? So let's think about routine 1. So in routine 1, she burns 10.5 calories for every minute that she runs. Okay? So we have two unknowns here, the number of calories total that she burns and the amount of time. So I'm going to go ahead and label. I always like to write down what my variables stand for. So T is the time, and I'm going to call C the number of calories. So for routine 1, I know the number of calories is going to be 10.5 times T, because it's for every minute she burns 10.5 the calories. Now so that's routine 1. So routine 2, she burns 26 calories walking, okay, and then she runs at a rate that burns 5.3 per minute. So the number of calories she burns for routine 2, she starts off with the walking, and we know that's just flat out 26 calories. Plus, then she has to run at the 5.3 per minute, so that would be 5.3 times T. So remember, when you're seeing something that says it's something per minute or whatever, you're going to multiply. Okay, so that's one of our little keywords. So we've got two equations here, one for routine 1, and both of them describe how many calories are being burnt. Now, when will routine 1 burn more calories than routine 2? So we want the first one to be greater than the second. So that tells me then my inequality is the first routine has to be greater than the second routine. And let's just solve that inequality. So that's a 26. So let's see, I've got my addition here. I'm going to subtract from both sides the 5.3t. So what do we have when we subtract that? So 5 minus 5.3 would be 5.2t. Has to be greater than 26. And then I'm going to divide by the 5.2. Now keep in mind, when you're solving inequalities, if you divide by a negative number, then you have to flip that inequality sign. But since 5.2 is positive, we don't have to worry about it. I just wanted to mention that. So in this case, t is going to be 5, so it's going to take 5 minutes. So anytime more than 5 minutes, routine 1 is going to burn more calories than routine 2. All right, I hope this helps a little bit with these word problems that you'll find in this section. And if not, I can go over some more examples and stuff.